this example that I have here is from page 49 of your Basics of Perspective. And this is at the end of the inclined plane explanation, going through the entire process of having to do inclined planes on different angles. So I wanted to show you the final version of it, just so you could see, you know, hey, that's kind of cool looking. I mean, look at all the detail and everything. But essentially, this drawing is based on a very, very simple one-point perspective room. It's a box, a one-point perspective box, with a series of one-point perspective inclined planes. Okay? It looks complicated simply because there's a lot of detail on it. Okay? I drew all the bricks on the side there. That creates your radiating grid, so to speak. It's a form of grid. And you can see that the floorboards and all that stuff are wood, and there's railings and windows and arches and things that go off into the distance, and more arches down here. So I'm creating a whole series of depths and planes that take you into the environment. But yet it's based on very, very simple one-point perspective. So here's the actual rough version of it right there. That's what we did with the stairs. That's what this is here. Except I didn't draw in the actual stairs themselves, but those are all the inclined planes for it. Okay? So to go from this into this is just a matter of adding detail to it. This is just a bunch of extra lines that say those are bricks. This is wood. That's all it is. Okay? Once you understand this is simple. Okay? It's time consuming, but it's simple. It's based on design. So, I mean, this is from my imagination. It's not like, you know, I looked up a book on castles or anything like that. It's just bricks and stairs. That's not too difficult to figure out. So, what I like to do is every so often I'll pop over to chapters or something like that, and I'll look through their books on interior design. I mean, I'm not big into interior design. It's not like, you know, if you were to go over my house, you go, whoa, really nicely designed house you got here. I like what you've done with the place. And that's not me, it's my wife that does that. But I like to look at how things are put together. And I do have some reference books that I bought over the years that if I need to, I can always go to it for reference. Like, there's an example over the past summer. I've been doing an internship with my students from second year in, and one student from first year last year, where I would give them a set design and they would build it in 3D for me. So I had one student who did an amazing job on a pirate ship, and I don't have the website address for it, so I can't show it to you. Next week when we come back into class, I'll pull that stuff up and I'll show it to you. But basically it was a pirate ship. And so what I had to do is I had to come up with the initial 2D drawing designs. I've never been on a pirate ship. I don't frequent shipyards all the time. I know generally if you said draw a ship, I could draw you an icon of a ship, but I don't know all the details of it. So in order for me to fully understand how this ship was put together, I had to go out and buy a book on pirates. Okay? It was one of those reference books for kids. And it had tons of photographs of model kits and stuff like that and reference material. And I used that as I was designing my actual pirate ship. And I modified it and made it kind of funky looking, you know, where it had weird angles and stuff like that on it. But basically, I had to find some reference in order to get the actual detailing for some of the stuff. I mean, I knocked it down quite substantially so that it doesn't have all the rigging and, you know, tons of lines and stuff like that. It's probably got maybe 5% of what it really should actually have. But if you were to look at it, you'd go, yeah, that's a pirate ship. Okay? And again, that's essentially what we want to do, is we want to create images that people can understand immediately as soon as they look at them what it is. So this type of stuff here, this is just detailing to fill in the blanks of what the different things are. So in some cases I had to sort of think about how is this thing put together. So I've got this piece of wood that's off to the side here that's holding each of the planks of wood that are for the stairs, and you know there's little rivets or nail heads that are sort of going in there and holding that on. Now realistically, if you were to walk up those stairs, this railing would not perform any real function because it'd actually be fairly rickety. But you know, again, you can suspend belief to a certain extent. It's an icon, and when you look at it, you go, yeah, that would support someone's weight. But if you just sat and looked at it and said to yourself, one nail to hold in this piece of wood? I don't think so. That's not going to support anybody when they lean on it. They just sort of fall over into the abyss. But you suspend the disbelief of things like that, because you're not necessarily really looking at the details. You're looking at what's the character doing within this environment. All right? So, as I mentioned before, this is the final version of the rough of the whole thing, but then what I've done is I've gone through and step by step explained, here's where all these lines are going from and to, in order to create the illusion that this thing is actually working. So that's basically where I started off, right there. Okay, it's just a one-point perspective plane, which, if we go back to this, that's this plane right here. So I started off with my vanishing point, horizon line through here, established this plane, and built everything from that point up. And just kept adding and adding and adding until I got the final version of what I wanted. Okay? So that's basically what we're going to be doing as well. So what I want to talk about now is I want to introduce you to the idea of finding center points and measurements on boxes. So let me just widen this out a bit. Okay, so what I want you to do is, again, let's place our horizon line across your sheet of paper like this. We're going to just do a simple one-point perspective here. And remember, when we're looking at something one-point perspective, that means that we are parallel or looking straight on at the wall or the object that we're viewing here. So what I want you to do is draw a parallel line down here below. And choose your endpoints. So we're following the same process that we did in your room. We had a horizon line. We selected vanishing points. In this case, we've got one vanishing point. We selected a corner, a line that represents the corner of whatever it is that we're drawing. So in this case, we're just going to draw a little one-point perspective plane. And we simply decide arbitrarily, well, what are the endpoints? And from those endpoints, we end up with connections that we now extend through to the vanishing point. And then we have to make a decision as to how deep is this object. And you can make it whatever shape you want. You can make it a rectangle if you want. You can make it a square if you want. Doesn't matter. If you want to try and make it into like a square, then that'd be kind of cool. Help to explain things a little bit better. But we're just sort of going to bisect it like this to create a little one-point perspective plane. Now, let's say I want to find the center of this plane. I want to find out where the exact center of it is because I want to put another box, or I want to put a, I don't know, a pole sticking out of it or something like that, and I want to know exactly where it is. I could guess and just sort of say, well, it's somewhere roughly about here, maybe. I don't know. That looks about right. And, you know, if it looks right, then that's okay. But there is a way to find the actual center, and that's by going through the corner, the two opposing corners like this and this, extend a line across like that, and then you go through the other opposing corners, and where those 2 points crisscross each other, that's the center of your box. So what that does is it establishes a depth so that your distance from here to here is greater than your distance here to here. So it's creating a perspective feeling to it that creates that rule of perspective. The closer something is to you, the larger it appears, the further away, the smaller it appears. So this front edge of our plane, the width of it here, is greater than the width here. That's why we use our vanishing point back there. So that gives us an accurate positioning for where our vanishing point is going to be. Now let's say that we want to create another box that's behind it. And we want to have that box in proportion to this box here, the same size as this one, just receding off into the distance. What we can do is we can take this line here and extend it through to the vanishing point, or to the horizon line, sorry. And where that line crisscrosses through there, we use this point to then go through this corner here. So we went through this corner first. Now we're going to go from this corner to that point over there. And where those two lines right here crisscross each other, that's where your next line goes horizontally. And then to find the center of this one, you just crisscross through your corners here, and that will give you your center for your next point. So now if you want to draw another square going back, you go again from that corner, farthest corner away from you, back to the point that's over there, where that line crisscrosses through. That's the depth of the next one. Now I'm off a little bit there. I wasn't accurate with it because my pencil has started to get dull. And this is something I had a conversation with one of the students as we were coming back here. He was saying that I'm drawing my grid on the wall, and when I'm drawing it, what ends up happening is I get one square that works out really well, but then all the other squares below it, they turn into rectangles. That's usually because of the height of your line, whatever height you chose here, you didn't subdivide it equally, properly. Like let's say you do something like this. Okay, so the distance from here to here is the same as here to here, but this one here is greater, and this one here is smaller. Well, as soon as you project your lines out, automatically it's going to change the size of whatever this box here is in relationship to this box here. This one's going to be more of a rectangle, and this one's going to be more of a square. So unless you're 100% accurate with where your lines are going, things are going to get skewed off. So just by doing that, I've automatically changed the proportion of that box in perspective, and it's not as accurate as it could be. So it's actually smaller than it should be. Now, this trick that I've created here, if I continue going back to my vanishing point here, I'm just noticing as well that I was off my vanishing point on that line to start off with. But if I continue to do this across like this, what I can do is I can create a series of lines that are equally receding off into the distance. And if I turn the whole thing sideways, it's like telephone poles going off into the distance. So if you want to draw items that are equally spaced, that are logically going off in the distance, like a telephone pole, or fence posts, or maybe buildings that are all equal sized, or if you turn it this way, you want a sidewalk, so that each of the squares is the same size receding off into the distance. That's the trick you use, going off to that vanishing point on the side. Right? But now the thing is, you have to make sure that whatever shape you use down here, that it actually looks like a square if you want to make them all look like squares. Okay. If I changed it so that it was a rectangular shape, and let me just do this on a separate sheet of paper here. Let's say I do exactly the same thing that I just did. I just won't draw the horizon line, but I've got a vanishing point that's right here. Here's my leading edge and the width of it. I go back to my vanishing point here. Okay. So instead of creating a square here, let's say I turn it into a rectangular shape like this. And I go from this corner through to this corner here. It's still going to give me my center if I crisscross through the other one. Here's my horizon line right here. But it brings this point in. So that when I go to my next one here, and crisscross through this line and then draw it parallel to the horizon line this way. Okay. It's going to keep this in proportion, but it's going to get smaller quicker as it goes back off in the distance. So this one will look like a rectangle this way. This one starts to turn into a square, and when I go to my next one, it's going to scrimp even harder to a smaller size, so it turns into a rectangle the other way. Okay? It's turning into a rectangle this way because it's shortening up so much here. And that's simply because this point is closer to my vanishing point over here. So it alters the perception of those going into the distance. So you just have to be careful. Okay? There's nothing wrong with it if let's say your telephone poles are actually that distance apart. It's not like they're square. The height is equal to the depth. Then that's fine. Okay? But eventually it's going to get to a point where these start to really bunch up quite a bit, like this, and get very, very tight, and you have to make a decision, does that look right? At which point you might want to shift your lines over a little bit. Okay? So it's an interesting little guide to try and get you to the point where you understand the depth and making it equal in distance, but it's not something you can 100% always rely on if you're not accurate. Now this brings us to the point of ellipses. An ellipse is essentially a circle turned on its side on an angle. And so if we take, we just grab something here. For the sake of being accurate, I'll use my pop here, but I don't want it to spill. I'm just going to turn on its edge here, and I'm just going to draw a circle here based on the bottom. Okay, so there's my circle. The circle, and again, it's distorted on your screen there, but on the camera it's accurate. If I take the width, it's here, from here to here, whatever that measurement is, and it just happens to be 6 centimeters, okay? If I take this here to here, that's going to be 6 centimeters as well, and it is 6 centimeters, okay? So the width is equal to the height, so any point, any angle that I choose to measure this, it's going to be 6 inches, because it's a circle, right? It's equal distance all the way around. So if I want to find the center of this circle, I go through my corners on my square that I just created here. And it creates my center. Okay? That's dead center of the circle, which is the same as this theory here. Okay? Now, the problem is that if you use this system to create a grid, that if I go through the center in this direction here, okay, you can see that physically the distance from this line to this line is greater than the distance from here to here, right? So that just proves our theory of perspective, that something that's closer to you is bigger, something that's further away recedes and gets smaller. So if I actually measure this distance here, it is 2.5 centimeters. And the distance up here is 1.5 centimeters. So it's actually 1 centimeter smaller here than it is here. Okay? Now, this is the width from here to here. That represents the width of my circle. So if I use this and draw a line across here, okay, this line is this line right here. There's the width. Okay? That means that if I draw a line this direction here and bisect the circle this way, okay, so it's turning into a pizza. If I do the same thing over here and go from my vanishing point through that center point, this will also create a bisected square pizza. But if I want to turn it into a circle like this, what I have to do is I have to round out my edges here. And so in order to do that, I know that this point here is touching, this point here is touching, this point here is touching, and this point here is touching, because those are these points right here. They're all touching on that circle. But these points here are not touching anything. They're actually in from the corner. So I have to figure out where are these points right here and here. On here. Okay. So what I have to do is I have to draw a semicircle from this point here around like this till it kisses this corner here, and bring this around in this direction here until it kisses this point here. And then the same thing on the back side over here, bring this around until it kisses there, and then loop this around this way until it kisses there. All right? Now, that's a proper perspective ellipse, but it's not correct. Okay? The reason for that is that when I take this, okay, this point right here is my pivot point, so that when I turn the ellipse sideways, it's going to bend at this direction here. This distance remains the same all the time. Okay? And this line is actually physically bisecting that ellipse exactly in half, mathematically, from a measurement point of view. This does not. Okay? The distance from here to here is greater than the distance here to here. So what's being created is the illusion that this part here is coming down like this, and it's dropping off of an edge here. So it has, from a side view, it looks like this. Okay? Because perspective says that this is less here, but this is greater in distance. So it has this drop-off feeling to it. Does anybody here have an ellipse template or an ellipse guide? Anybody have one?
Not here.
No, I wouldn't expect you to. But if you look at your ellipse template, what you will see is this. You'll see an ellipse, whatever degree it is, and it comes in 10, sometimes 5-degree increments. But you'll see an ellipse that basically looks like this. And on the ellipse template, this area here is cut out, and the rest of it is plastic around it. You'll see a line here, a line here, a line here, and a line right here. And what those lines do is they indicate the exact mathematical halfway point of the ellipse. Now, I wasn't accurate at that because my distance here to here is greater, but this should actually come out more like that. So that the mathematical distance from here to here is exactly the same as here to here. Okay? And so what that ellipse does is it creates the proper depth perception and rotates that circle on its proper angle to eliminate this problem here. So although technically from a perspective point of view, this is the correct way to determine where your ellipse is, it doesn't work visually. Because you're always going to end up with this point here being larger than this point here. And in actual fact, your widest point on your ellipse is right through the physical center on the side. So what you need to do when you're drawing your grid is, if I go back to a blank sheet of paper here, when you're trying to draw an ellipse, here's what you do. You use the exact same start-off point that I did before, with my vanishing point being up here. Draw my plane. Off like this. Draw a line across there. Then what I have to do is I have to mathematically measure the distance from here to here, which is 4 centimeters. So I find 2 centimeters here, a mathematical halfway point. Connect that through that way, and then find my center point, the halfway point between these 2 points here, which this is 11 centimeters. So therefore 5.5 centimeters from there through to my vanishing point is the center this way. So that means that this is going to be my kiss point here on this side. And when I draw this around this way, and this way over here, this will be exactly the same. It's actually a mirror image of what I've done on the opposite side. So this will create a proper looking ellipse. It should actually just be rounded a little bit more. Okay, so there's this way of doing it. And then the other option is to simply go out and buy an ellipse template, stick it down and draw your ellipse from the ellipse template. Okay? That's what they make them for. So why not go out and buy them and use them, right? I've got a full set that goes from, I think it's 20 degrees all the way up to the 90 degree or 95 degree angle, which is a circle. And they come in different sizes. So it actually comes in a really nice binder. I think it cost me like 50 bucks. But I use it all the time. Anytime I'm doing an ellipse, I just pull it out and use it. Okay? That's what this is for too. It's a ruler. It's manufactured to create a straight line. Okay? So if you want to draw a straight line, you use a ruler. If you want to draw an ellipse, buy an ellipse template. Okay? You can still block out your basic shape that you want it to be, the plane that you want it to be on, and then match your ellipse guide up to it. Because this can be frustrating sometimes. If you're not absolutely 100% accurate with it, it'll just sort of throw it off a little bit and you'll just be going, ah, I can't draw ellipses. Okay? I find drawing freehand ellipses very difficult. But if you got a template, pull it out, use it. Okay? So, from that point of view, like, I don't mind if you guys cheat a little bit from the idea of using guides to help you. Okay? So, if, let's say we get into a circumstance where, I don't know, let's say you don't have enough money to afford an ellipse template set, okay, but you have access to a computer that has Photoshop, which just happens to have that little tool that allows you to create circles and ellipses, okay, go ahead, use it, okay, create an ellipse, print it out on paper, trace it off. I'm okay with that, all right? There's nothing wrong with using that type of stuff. Just don't get overboard with it where, you know, you're plotting out all your perspective in Photoshop using the ruler tool. It is a helpful tool, but again, we are drawing on paper. So only when you get to the really complicated stuff like ellipses, then, you know, default to a computer if you have to. But for the rest of the stuff, just use a ruler and a pencil. Right? So that's one way of finding your ellipse on that. And simply by shifting your plane over further, so let's just say I put a vanishing point that's over here, and I take and I push my line that represents the edge over this way. What that does is it opens up the plane further here. So if I create a square here, okay, this now opens the plane up wider, so it's turning into more of a circle. So I don't even have to find my halfway points. I mean, I could just guesstimate that they're roughly about there and there, and there and there. Then I know that I've got to fit my circle inside this shape right here. Now you'll notice that when you draw yourselves, you'll notice that this side of the circle or ellipse is easier to draw. The reason for that is because I'm simply putting my knuckle, these two knuckles here on the paper, and I'm pivoting. I'm just allowing the natural rotation of my finger, and yeah, I'm moving my finger in and out a little bit to match up to the angle. But you'll find that when you go to this side here, this is awkward because you're having to go, ah, pull your finger in. So this side will always end up looking a little bit flat over here. So you want to see a trick to fix that up? Turn your paper upside down. Okay, makes it easier to draw on this side here. Just rotate your paper, turn it around, and then you've got a better ellipse. Okay, so again, you can do it freehand, you can do it with an ellipse template, whichever way you want. I'll leave that completely up to you.